Um, yeah, so before we really start getting into Kirana network and typing away and building the application, it's kind of important to really understand what the architecture currently looks like. Just because we're doing this effort of um, this whole live streaming is about building on top of an application that already exists. So I'll just kind of explain what um, are all the different pieces that are currently part of Fleet en route, which will eventually become Kirana network, including how it is now and what I plan on doing with it in the future. Um, so there's a few parts. There's a few parts to the entire Fleet en route architecture. I'm gonna start. It won't look pretty, at least until it's fully done. I'm not gonna bother with like icons or anything, but I'm gonna just start putting together different pieces and explain how things are interconnected. So at the core of everything, we have the API. It's built with Typescript and NestJS. I'll get into the details why NestJS is pretty cool, but if you do your research, you'll probably decide whether it's a good idea for your own application. So, this is the REST API. I want to just make a distinction. And we also have a WebSocket API that's also built using TypeScript and Nest. I don't think it's using NestJS, standard type. It does a very few different things of maintaining different connections for users, so that when the package is en route, we can let the user know where the package is. It does it in near real time. We have to slow it down just a little bit to make it once every 5 seconds. So anyway, yeah, it's near real time. It can be faster than 5 seconds, but I'm just throttling it for every 5 seconds right now because it's good enough. 5 second. Also have a mobile device that is for the drivers. That's on iOS and Android. And we have our databases. That is built using DynamoDB. And there's 3 different tables in this. One is for the WebSocket connections. The second is for the data. We use the partition key and sort key approach of putting different types of entities on a single table. It's pretty performant. There's a recommended there's a article on DynamoDB on how to use this properly. So if you're interested, you can just check out partition key and sort key design on DynamoDB, and you'll find some good talks on started. Also have Shopify. We have a extension into Shopify and the database that we use for the data. I'm just gonna do this separately, but it is also built on top of DynamoDB. It makes sense why there we go. Okay. Database. We also need to talk about the front end. There's 2 front ends. One of them is like the marketing side type of front end, which just explains what the application is, and it kind of puts bouncing off point for different services. So that's just we call it the this portal. One of them is the main website. We don't need to talk too much about it. It's just there for just bringing users in. But the other website is more portal, and that contains all the necessary functionality for businesses to be able to invite their drivers, manage the orders, set up a Stripe account and that sort of stuff. We also have an integration into Near, which, for lack of a better icon right now, it's this one. And this currently only has a smart contract that will help you track the order status as the status changes. So if it's created, or it's canceled, or if it's in progress, or if it's been completed, that sort of stuff, every event is tracked against an order on that smart contract. We don't delete the orders unless, well, yeah, I don't think we delete any orders. It's there on this record, and it's on the test net. So we also have Stripe. We use Stripe to expose a couple of different products. One is if you want to just use this application without putting anything on the blockchain. There's one product for that. Users can just basically use it. And the other one is if you want to opt in for the feature of having everything logged on the blockchain. Oh yeah, I haven't put the Shopify portion here as well. Got the Shopify app. It also has a database, DynamoDB. The Shopify front end is built on top of. I'm going to package everything in Shopify in a single block, but there is a front end for it, and it's built on top of NextJS, and the database that it's using is built with. Well, it's using DynamoDB. So how is everything connected? Well, there's gonna be a lot of arrows, but mostly because the REST API powers pretty much everything on the application. So start putting things in some kind of a logical order. So put both of our APIs together, and everything's deployed on top of AWS. So, yeah, so I'm not going to draw everything under it. I'll just have a little marker over there. There's the near stuff. All right, so there's not a lot happening with the main website. We'll just leave it here. There is one feature that it provides that we're interested in, but we'll get to it in a bit. So the portal. Right, so time for drawing. All right, there we go. Get me the arrow, please. Yeah. This. What I was hoping to do. Oh, much better. Okay, let's just get it double arrows. First the arrow. Okay, so the portal primarily talks to the REST API, and it does a ton of different. It uses it for a ton of different stuff. That is, create user, create. Well, basically, CRUD actions on users, orders, drivers, customers, etc. We also have data store. So whenever a order is created and it's associated with a driver, there's no notifications on the driver app, but the driver app can retrieve that information. from the API. Just split this. We gotta turn this around. Okay, so what is a driver API to? It's going to ask for the deliveries for the day. First one, a little bit. Okay, perfect. Yeah, it asks for deliveries for the day. So, and then the second part is update the location while even though it's possible to get the location of a driver all the time, it's just not right to do that. So the location is only transmitted out of that phone if the person is actively on a delivery. So what happens is we make an API call to the GPS unit endpoint, tell this is the current location, and what happens is there is an internal. Oh yeah, I forgot to mention. So there's a AWS feature that we're using. It's called Event Bridge. What it will do is whenever the location of a driver changes, we send a notification to the event bridge. There's actually a ton of different notifications that can be sent. So one of them is GPS unit update. The other one, if I recall correctly, the other one is also, what else? Oh yeah, when someone is invited, driver invitation. So usually anytime there is an event that we want to act on, but not immediately, we just push it off to the event bridge. And there are several different Lambdas that are connected to this. I'll put that over here. These are like one-off Lambdas that do just a single task. So whether it's like sending an email to invite somebody or the GPS location that's been updated, we can do that. So there is a Lambda. There's a bunch of Lambdas, and this particular Lambda happens to be handler for the GPS update. So if the way Event Bridge works is it takes in an entire JSON object, and you have certain rules. If a part of that JSON object matches a rule, you can connect it to an endpoint. And in this case, the endpoint is the Lambda that's supposed to run whenever the GPS unit update has been detected. It doesn't have to be for one driver, it has to be for anyone. The fact that the location has changed just triggers this Lambda. Do now is there we go. And one of the jobs of this particular Lambda is to call the WebSocket API. The reason why we use the WebSocket API is that on the main website we have the tracking page, and when the user is looking on that page, they want to know where their package is, right? So whenever someone goes to that particular page, we kind of register that page to be a listener on updates for that particular order. So whenever the GPS updates on that particular order, the message is sent to the WebSocket API, which will then send a message over here immediately that says, hey, the location has changed, this is where the person is, this is the kind of route that they're taking, that sort of stuff. Update. Where does Stripe come in? Yeah, so we also, as you can see that there is Stripe. I'm just going to move it over here just because it's probably a little bit easier with the diagrams. And I may be skipping over some of the details because I don't want to draw arrows all over the place. There is a little bit of back and forth with these building blocks, but at a high level, I just want to make it easy to understand rather than draw every single thing that tends to happen. There's another Lambda over here. This is for the on order created. So the way billing works right now is that every time we charge the user for every order tracked. So every time an order is created, this REST API sends a event bridge notification to a notification to the event bridge to say that an order has been created, and there is a listener that's particularly interested in that event. So when an order is created, it just says, okay, let me go to this this client on Stripe, and we'll make an update. We'll just increment the auto increment. Stripe builds based on usage, so we just increment that usage by 1 every single time an order has been created, and then Stripe just sends the bill. It takes care of the billing aspect. Talk about Shopify as well. We do have a Shopify extension. What it's doing is basically allowing folks to sell stuff on their Shopify pages, and every time an order has been created, it lets the admin in the Shopify app basically have a choice to opt into local delivery, and if they do that, they just connect that particular order to be fulfilled through Fleet en route, and that means they're assigning it to a driver through Fleet en route. And the way primarily Shopify talks to our API is again through this REST API. This is the entry point into a lot of the features. So it will use the Fleet en route API to create basically the same thing. It's doing CRUD orders. You might be wondering, like, okay, if you're using this API to do CRUD orders, what's the point of having a DynamoDB database? The reason why this database exists is because the data is coming in from Shopify. There is slight differences between how Shopify treats that data and the variable names. Rather than trying to fit Shopify entities into the main data table, we just have another database for Shopify, and we just have like a two-way sync between Shopify and Fleet en route. The way it does that is whenever the database record changes on Shopify, there is a corresponding change event that's triggered. Let me bring this back. There is another Lambda. Paste this over here. So typically Shopify app does not talk directly with Fleet en route. It will utilize this particular Lambda. It's called on database record change. Not exactly what it's called, but it's easy to explain. How do I hit large? I cannot find it. Okay, there we go. So this is the Lambda that is called whenever the database record changes. This one will call the Fleet en route. Handles the CRUD. So whenever let's say the order is created, we add a record to the database, and obviously this is triggered. It will create the corresponding order in this in Fleet en route, and if they delete the if an order has been deleted outside of the scope of the Shopify app, we do have another event bridge that we're using to connect with all of the just gonna call it Shopify Lambdas, and there's one of them for record change, Dynamo trigger, and then the other one is Shopify webhook events. there's two ways to connect Shopify webhooks. You can create an actual API endpoint to do this, or at the same time you can connect it through an event bridge. The better option is to use event bridge, just because if you have a flurry of events that happen, you better make sure your so let's say you use an actual API endpoint like /webhooks or whatever to take the incoming requests whenever something changes. If there is a spike in events and your API is not capable of handling all those events, you will end up dropping some of those webhook events, and that leads to poor integration. So the other option is to use something like Event Bridge, and they do offer an Event Bridge connection to AWS, so that's what we were using. So anytime Shopify, the record changes on the Shopify side, there's an event bridge that's listening to those events, and if we're interested in one of the events that we want to act on, it just calls the Lambda function that's supposed to that event, and again we go back to the REST API, manage the states. I think so. Okay, now let's talk about near. So similar to how we have the order created, we have another endpoint, like we have another Lambda that is going to run whenever the order changes. And if the user opts to have the near protocol as the blockchain to track these events, we just send we just basically call that smart contract and log the fact that the order has changed. And that again is run by the event, like it's also covered by the event bridge. Order created, order changed. So in a large degree, like this is the REST API is the main entry point to a lot of different behind the scenes features that, well, it's an entry point into any record change that needs to happen on the application. But these record changes are tied to different downstream events that need to happen, and that's all bridged together with Event Bridge, and on both sides for Shopify specific Event Bridge. This is, I'm gonna call it this one, the default Event Bridge that's on the account. So that is kind of the existing architecture. Let me see if I can zoom. Hard to see the whole thing, isn't it? So I'm gonna just zoom out just a little bit. Everything can be seen. Move these. Not gonna look. That's probably the best. That's kind of what it is. That's the current architecture. We want to talk about where we want to be in the future. Copy the whole thing over. The next tab. So I'm gonna make Stripe a different color because not actually. So Stripe, I want to make Stripe optional. Now we're putting everything on the blockchain. We have the option of giving the customers the option of paying with near whenever a sale is made. So Stripe is not necessary. It should be an optional payment method. So rather than this, we could have the trying to figure out the best way to reorganize this stuff, but still making it right in the new way. In the new In the future plans, the website has a lot more, has a bigger part to play. So it's not just a tracking page. It is also the page for the users. When I say users, the customers, to be able to create its marketplace front end for the customers. It is also a payments page for the marketplace covers payments, right? It is also a tracking page for the orders. It is also admin page for the businesses to be able to manage the way they want to use the application. That actually means that this portal will now be going away. Everything kind of comes into one place that just talks to on our API. And all of this is powered by that drawing over there. And the app stays the same. The Shopify side stays the same because Shopify has its own way of managing things. They prefer payments to go through Shopify, so you don't have to worry so much about the payment stuff. In app, yeah, I want to expand a little bit on the near side of things because what's happening is the way I plan on doing this is to allow each business to have their own smart contract that manages all the products. So there is less. Oh, close this. I want each business to have their own smart contract that manages all catalog and the payment, that sort of stuff. Just give them more control. Even though to start it may be custodial, there is always an option to kind of take off and kind of do their own, manage everything on their own. There's going to be for each business. However, when you're primarily putting data on the blockchain and retrieving it, things may always be slow. There's going to be another Dynamo table that's just there to cache the correct representation of what's on the blockchain. So that's going to be for lack of a better word, I'm just going to call it the marketplace catalog. So kind of what I want to do. At the same time, users can, in that smart contract, there will be a place to specify where the payment is supposed to go. So if when the order is created, payment has been sent to the kirana.network address, then that's good enough for that particular order. So you don't really need Stripe. You don't need also about one order created. It simply will just check that for this particular order, has a payment been sent to kirana network's main address or one of the addresses. That's it. If I remember something else to add, go ahead and. Oh yeah, so we also want to extend the mobile application. It doesn't have to be just a driver app. It would be ideal if it's an app for the drivers and the customer. Otherwise, it can just have a second app as well. That's just facing it. Like that's for everybody. You just go on there and shop. It's kind of like the Amazon or eBay apps or whatever. It's general.